Good morning. I'm Chris Mooney. I'm a climate change, energy, and environment reporter here at the Post. So I'm really excited to kick off today's panel. We have Dr. Heidi Hammel, planetary scientist and executive vice president of the Association of Universities for Research in Astronomy. We have Bill Nye, CEO of the Planetary Society. He informs me that he delivered the Washington Post. So from there to the stars.
It was some time ago.
And last but not least, NASA Administrator Jim Bridenstine. So we have a great panel. Before we start, I want to let the audience know you can tweet your questions at us using the hashtag Transformers. Apparently they will travel through space, and I will then receive the questions on this iPad, or that's what they tell me. And I will work some of them into the discussion as we go. So with that, oh, and one more thing, I told the panelists, interrupt each other, let's have a conversation. So Administrator Bridenstine, I'd like to ask you a question first. The United States was intensely focused on space in the 60s during the Apollo era. It was something that presented this unitary, shared vision for the entire country. What do you think it would take for us to see another golden age in space like that? What would it look like? How would we know if we were in it?
That's a wonderful question, and certainly it's something that we're very interested in NASA, and certainly something this administration is very interested in. The president recreated the National Space Council for the first time in 25 years when he became president, and he put the vice president as chairman of the National Space Council. And in fact, when I leave here, I'm going to a National Space Council meeting. So this administration is very focused on space on a whole lot of levels. But certainly, one of the very first space policy directive that came from the president was we're going to go to the moon. But what he did is he wants to do it very differently than we've ever done it before. This is not a recreation of the Apollo era that we all think so fondly of. This is, in essence, creating a sustainable architecture between the Earth and the moon where we can go back and forth over and over again over a long period of time with landers, with robots, with rovers, and of course with humans, and do it with commercial partners and do it with international partners, utilizing the resources of the moon to keep the sustainable architecture in place.
Let me just follow up on that. So one thing that I learned from NASA, doing my research, is that its budget during the Apollo era peaked at 5% of the entire federal budget. So the administration, as you said, wants to get to the moon and beyond, but how do you do it and support the crucial science missions with so much less money proportionately?
Right now, it's about 0.4%, right?
Yeah, that's right.
So it's less than a tenth of what it was.
It's a very different time. So that's the...
Yeah. So the first thing the president did is he put out his budget request, and his budget request actually took NASA's budget up by $1 billion. So when you have a $19 billion budget and you go up by $1 billion, that's a pretty significant increase. And even before I got confirmed, we had an omnibus appropriation bill in the House that actually increased NASA's budget by $1.7 billion. So we're seeing bipartisan support and support from the administration for a budget increase. Now, I think it's important to recognize that when you talk about the budget as NASA's budget as a percentage of the federal budget, we have to remember that a lot of the federal budget has grown significantly, and so while it may be a smaller percentage, it's not necessarily because NASA shrunk, it's because the rest of the government grew, if that makes sense.
Fair enough.
Before we move on, can I talk about the golden era and what that meant as a scientist, a space scientist? That era, I was just a kid when we landed on the moon, and I was one of those kids watching that black and white thing, not understanding what was happening, but understanding it was an amazing moment. And I went on to be part of the space program, to work on the Voyager mission, to fly by Uranus and Neptune. I went on to work with the Hubble Space Telescope. It has been a golden era of planetary exploration, and what we do at the Planetary Society is advocate for that. We have revealed our solar system not to be points of light, but worlds. Where are we now, though? We are on the brink of a new golden era. We now know, because of NASA's telescopes and telescopes by the National Science Foundation, that almost every star you see in the sky has a planetary system around it. So we have gone from just a few planets to thousands of planets. This is an amazing moment in science, to be on the edge of exploring all these worlds.
But isn't it different? And you know, Bill, you grew up in the Apollo era, and you're a communicator. So it seems to me, I want to bounce this off of you. Haven't we become kind of space distracted? You know, there was one story, it was getting to the moon. Sagan had one show, Cosmos, everybody watched it.
Well,
now
keep in mind, everybody, we went to the moon on account of the Cold War.
Okay.
I mean, it was a Cold War effort, and you could argue that it was successful. But then the amazing science that spun off of that has led to the internet and mobile phones and global positioning and all these other things, because space exploration has become routine, or in some aspects. And that's nothing but great. And to Heidi's comment, so everybody, what happened was I took one class from Carl Sagan when I was in engineering school. And now I'm the CEO. I left the room and there was a vote, and now I'm CEO. But there was estimated that there were maybe a planet around every 100 stars. Well, now we think, you know, in order of magnitude, there's 10 planets around every star. And this gets into the expression billions and billions. It really is amazing how many planets there must be out there. And so, as I always say, there's two questions we always ask. And if you meet somebody who hasn't asked these questions, they're lying to you. Where did we come from? And are we alone in the universe? And these are just deep, fundamental questions, and they're within us. And if you want to know the answers, you have to explore space. And everybody, to Heidi's point, it is very reasonable that we will find evidence of life on another world while we're all still alive, which would be astonishing. I mean, it would tell you, first of all, what if there's no evidence at all of life? That would mean, wow, we are unique in a way that's literally hard to imagine. But the other thing, it's very reasonable that we'll find life. Just think what it would mean. It would be like Copernicus or Galileo. It would be just fundamental. It would change the way everybody feels about being a living thing.
To Bill's point, because I think he's right. Just in the 6 months I've been the NASA administrator, we now know that methane cycles on Mars are perfectly in order with the seasons of Mars. We also know that there are complex organic compounds on the surface of Mars. This is just within the last 6 months. Now, that doesn't guarantee life, but it increases the probability that there is life. And it's up to us to find it. Also, since I've been the NASA administrator, we now know that under the surface of Mars, about 1.5 kilometers under the surface, we have found liquid water. These are astonishing discoveries.
So everywhere there's water on Earth, everywhere there's dampness, there's something alive. And so just think if there's Martian micro, I mean, it would be astonishing. And we do that kind of exploration.
It's not the only place in the solar system.
That's right.
Either,
Well, let's talk about Europa, for example. Yeah. Jupiter's moon Europa, which is a little ice ball, but under that crust of ice, we believe there's a liquid water ocean. And I want to tie this back to what Administrator Bridenstine was talking about, the human spaceflight program. One way we've been able to track the plumes of water we think exist on Europa is using the Hubble Space Telescope. And one reason the Hubble Space Telescope has been the most revolutionary tool in astrophysics for 28 years is because it was serviced by astronauts. It was launched on the shuttle program, and the astronauts went up there. They took out old instruments, they put in new ones. They took out old gyroscopes, they put in new gyroscopes, which are working again, in case you're wondering. And we do hope to be back on Sky with Hubble very soon. I'm very excited about it. So astronauts, the human spaceflight program works hand in glove with the science side, and I don't ever want to separate them. We need them both.
But that actually brings up something I wanted to ask about, which is the International Space Station. Administrator Bridenstine, you've hailed this new era of spaceflight, and this involves shuttling on board commercially designed craft to the station. But you've also talked about phasing out funding for this research hub and having the commercial sector eventually take over. So my question is, what happens if markets don't evolve in the way that we think or hope, and commercial entities don't find it worthwhile to do the kinds of things that are happening there now?
Yeah, that's a wonderful question, and it's an important question that we're gonna struggle with until we get the solution. The answer is this: we want to make sure we have zero gap in human presence in low Earth orbit and even beyond. We have had humans living and working in space now for 18 years straight. And we want to make sure that never stops. So in order to do that, we need to see a very robust commercial marketplace develop in low Earth orbit. And we believe that that's eminently possible. And what the president's budget request did is it said, hey, look, we need to start now very seriously considering how do we get to a day where commercialization happens in low Earth orbit. Now, if you go back in time to the Cold War, we came to the end of the Apollo program and we went right into Apollo-Soyuz, which was an international cooperation between the United States and the Soviet Union at the time. So that demonstrated the success of the Apollo program, the fact that these two superpowers have decided that we're going to collaborate and work together on space. That went forward with the Mir program and the shuttle program, which were a collaboration as well, and then now the International Space Station, as you've identified.
It's in NASA's charter. International cooperation
Absolutely.
is in NASA's. And so when international partners collaborate in space, the overall cost of whatever you're going to do might go up. Exploring Europa, for example, but the cost per agency goes way down, significantly down. And whatever else the space station has done, it has been fantastic for diplomacy.
Soft power.
Do you agree, does the Planetary Society agree that a commercialization fate is inevitable in the long run? Is that something that you're, no?
So I'd ask the administrator to comment on this. But now, some disclosure, I applied to be an astronaut 4 times. But it is not clear. Let's go with that.
Had I been the administrator, you'd have been selected.
Yeah, careful what you wish for, yeah. But it's not clear that we can go to the moon and to Mars and operate the International Space Station in the current budget, even with the increase in NASA's budget. Those 3 things all going at once are tricky. And the International Space Station is a national lab. So come on down, everybody, and fly up there and conduct things the way we conduct science, the way we conduct science in other national labs. But this is a problem to be figured out. Now, no matter what we do, no matter what the future is, I think we all agree we want to get beyond low Earth orbit. So, you know, the old saying, if you have a classroom globe, which in English units would be 12 inches, 30-centimeter globe, low Earth orbit is just it's 3/8 of an inch above the globe. I mean, it's cool, and I would love to go there, and we have some astronauts coming up in a few minutes, but we want to go farther and deeper. And you're a scientist, I love science. I'm kooky for science.
You're a science guy.
I am the science guy. But keep in mind that when humans go to a place, 2 things are going to happen. When you explore, when just writ large explore, 2 more things are going to happen. You're going to make discoveries, whether it's your backyard or Mars, you're going to make discoveries. But the other thing is you're going to have an adventure. And that is what engages us in a way that is priceless. Now, everybody, you can ask the old question, should we pay teacher salaries, build a new baseball stadium, or explore space? And I hope that if it was just a zero-sum thing, we'd pay teachers, okay, for crying out loud. But it's not one or the other. You got to do everything. And so the NASA budget is an extraordinary value. If you ask people around the world what they think of NASA, NASA is the best brand the United States has.
So, but I'm going to interrupt and lob a softball to Administrator Bridenstine.
Okay.
Let me share with you a vision of why I think we ought to move beyond low Earth orbit and get out there away, like we're not just an inch, but maybe, you know, to the moon or halfway to or beyond the moon, maybe even Lagrange too. The reason I would like to do that is because I'm imagining building with astronauts an amazingly large space telescope, larger than James Webb. Something that maybe we have to assemble in orbit, perhaps. I don't know.
Yeah. How cool.
Well, that would be amazing.
Or assemble on the surface of the moon, which is very quiet.
I don't know if I would agree with that,
See,
sir.
this is cool. Well, this is a real meeting. On the moon, no. On the moon, Mars. It's like I've been in this world for
But
21
on
years.
Earth, we're struggling with the James Webb Telescope right now.
Well, it's a hard problem.
over
No one's
budget,
ever,
it's
no one's ever tried
We've
to
never
build
built a
something like
James
that.
Webb before. You can't, like I was saying
I mean,
before, you can't buy a kit for James Webb
What is
telescope.
NASA's outlook on that? It's just
And of course, I've been on the Hill, of course, making sure that we are in compliance with the law, and we have great support from members of Congress on both sides of the aisle for the James Webb. Let me just say this. With the James Webb Space Telescope, what we're doing, we are inventing new things in order to put something on orbit that is going to not only see distances, but it's going to see back in time to the very dawn of light in the universe, the very beginning of space and time. We're going to be able to see that, the very first light in the universe. We have models over what that might look like. Bill Nye knows exactly what it looks like.
Oh, sure I do.
But what we know is that our models are not right, and we're going to learn a lot. We're going to be able to see out to the very edge of the universe. We're in fact the planets that we now know. All of these stars have many planets around each star. We're going to be able to not only see those planets, but we're going to be able to characterize the atmosphere around those planets with the James Webb Space Telescope to determine if those planets could be inhabitable or not. So this is going to be transformative. It's going to rewrite science books. Bill Nye is going to have a lot of work to do when this gets.
Bring it on.
It's worth a couple more years and a couple.
So,
more
here's the thing.
billion
But just to be
dollars.
clear, it will be able to do that work if we are lucky and win the lottery twice over and find systems that are close enough to us that will be within the reach of James Webb Space Telescope. And we do have the TESS satellite, which is looking right now. Hopefully it will find them, and maybe we will. I don't know if y'all bought your lottery tickets right now. It's super high, so maybe we can do that. But the reason I was talking about a future space telescope is we want to really be able to answer this question, yes or no. Do Earth-like planets around sun-like stars truly have the ability to be habitable? And we may not be able to answer that question with Webb. That's why we need to move forward. And you and I talked a little bit about this, and you said, don't say that, Heidi, and I'm going to say it anyway, because I think this audience understands this. Building a facility like Hubble or James Webb or some future space telescope takes time. You can't do it in a year or 2 or 5 or 10. You sometimes take 20 years to truly build a cutting-edge revolutionary facility. And that's true for many of NASA's great missions. And we have to understand that and just, take it as part of the reality that we work in.
And so for the politicians out there, when the NASA budget is uncertain, when there's a proposal to cut 5%, no, let's put back 10%. It's very difficult for programs to count on the funding and then make adequate plans. And so this leads to cost overruns.
Let me go to Twitter. Dr. Kim Binstead asks, I think this is directed at you, how can NASA reach its goals when the destination, the moon, Mars, et cetera, changes with every administration?
That's a critically important question.
Yeah, you've been here 6 months, man.
So here's the thing, and I think this is an important point to make. What we want to do at the moon is prove capability, prove technology, build this reusable architecture. So we want everything to be reusable. We talk about reusable rockets. We've seen what happens with reusable rockets. The cost goes down, access goes up. Well, we want the entire architecture between the Earth and the moon to be reusable. We want tugs from Earth orbit to lunar orbit to be reusable. We want a reusable command module in orbit around the moon. We call it Gateway. Think of it as a reusable command module. Can be there for 15 years. And we want reusable landers to go back and forth to the surface of the moon with rovers and robots and humans. And in building this architecture with reusability, that's how we get sustainability for the long term. And it's ultimately, this architecture can have American components, but it also it's open architecture. So the way we do avionics, the way we do data, the way we do power and docking, and all of the pieces that go into this overall architecture is going to be published on the internet. So if you're a country out there and you want to build a tug or you want to build a lander, you can plug into the architecture. If you're a private company out there and you want to invest in building your own lander, you can do that. And the Gateway is going to be available. This reusable command module is going to be available for your activity as well. So we want international partners, we want commercial partners, and here's the key to the whole thing. We want to prove everything is possible. at the moon, where it's a 3-day journey home. We know what happens if you look at Apollo 13, if something wrong happens on the way to the moon. You can make it home. If something like that were to happen on the way to Mars, you're not going to make it. So we want to prove technology, we want to reduce risk, retire risk, and then the first gateway, of course, is about a reusable command module at the moon that has maneuverability, can go to the L1 point and stay in that near rectilinear halo orbit as well. But ultimately, the second reusable command, the second gateway would be a deep space transport. And that's our path to Mars. Now, what we're doing is both, and we're doing it at the same time. But no, we're not, this is not Lucy and the football again. I've said that over and over again. Because we've had these programs before where we go to the moon and then we stop, go to the moon and stop. And I know everybody says it. This time is different. We have commercial partners. We have, so far, since I've been the NASA administrator, I've met with 24 heads of space agencies, all of which are excited about our return to the moon and eventually going to Mars.
So NASA is still 3 times bigger than any other space agency. It's still the world's leader in space. But the other space agencies and the commercial companies around the world do amazing things also.
Collaboration is the key here.
Collaboration is the key.
So
Absolutely.
one of the long-standing and sort of potentially sad, wistful ideas about the search for life in space is this idea that Sagan popularized, it wasn't originally his, that we might not find life because it has a way of burning up its own resources or wrecking its environment or just getting so technologically advanced that it
Well, this was nuclear war in the good old days.
Or maybe it's climate change, and so that's one sense in which it's potentially tied. The two topics are tied: space and what's happening on Earth. And so I want to just ask on this topic, Administrator, you've changed your mind on climate change. You say it's human caused. What do you want to do now at NASA to help us better understand this? And I also want to talk about. I mean, I guess you guys have talked about this topic a lot together. I'd like to hear about that.
So here's what we know. We know that carbon dioxide is a greenhouse gas. And we know that we as humans have put more of it into the atmosphere than ever before. And therefore, we are responsible for a lot of the warming that we're seeing of the planet right now. What NASA does, we do not want NASA to get involved in telling politicians what the solutions to the problems are. Because if we do that, we become very partisan, very political, very...
Scientists don't like to do that
either. We want to do dispassionate science. We want to build the sensors that are studying the Earth. We want to make all of that data and all that information available to the public. We want people to do their own research on the data. We want researchers to test each other's hypotheses. And so NASA is committed to dispassionately providing the data and the science and letting policymakers determine what to do about what we learn.
Including if they find something really bad, like it's going a lot faster than we thought, there's another feedback. They just let the chips fall where they may. That's how it's going to go.
It's up to the policymakers.
No, I mean the researchers. You know, NASA's researchers can just. I mean, imagine they find another methane feedback in the Arctic or something like that.
Well, speaking as a scientist, researchers are going to research. That's what they do. And people who are keenly interested in those kinds of questions are going to pursue them with all the passion that they have, not only on Earth, but also trying to understand how Mars turned out the way Mars did and Venus turned out the way Venus did, and yet they're all in our solar system. So you're not going to stop the researchers. They are going to passionately pursue these questions to try to understand how our Earth is changing, why is it changing, and looking towards planets out beyond ours, perhaps get an understanding of maybe how did we get here? Where are we going?
What happened at these other planets? So for me, of a certain age, it was a convergence of, let's say, Carl Sagan and James Pollock writing a computer program saying what would happen if all these nuclear weapons went off at the same time. You'd have a big cloud of darkness. People looking for oil off the coast of Mexico found this huge crater. And then principally James Hansen was looking at Venus and realized the strength of the greenhouse effect on Venus. And these 3 things came together in my lifetime. But it took a decade for people to realize that human-caused climate change was happening. And so it's this slow motion problem. And NASA has a huge role in showing us what's happening as the slow motion speeds up. So thank you, Administrator Bridenstine, for leading on this issue, because the data you have to respect the facts. It's just very important.
Well,
but here's what I was saying: is studying other planets is how we found out what's going on our planet.
Yeah.
And the cost of exploring those planets is so low compared to what we learn. Comparing the climate of Mars to Venus to Earth, it's amazing.
To that point, we also know, because of work that NASA has done, we know that Mars used to have a really strong magnetosphere, and it used to have a really thick atmosphere, and it used to be covered. 2/3 of it was covered in an ocean. Something happened.
What happened?
The question is, what happened?
What happened?
Was it 1 billion years ago? Was it 2 billion years ago? And ultimately, how did that happen? And studying other planets, right. So studying other planets helps us understand our own.
Yeah. So now we're calling Mars an ex-ocean, a former ocean planet, because there's so much, there's so much evidence of water flow. And
so the space has long been a traditionally bipartisan space, right?
It's that people who don't get along about anything else get along with space, and that's why.
So, and the two of you, I guess, have not always seen eye to eye.
There's issues we might disagree on.
But you've gotten along on this. I mean, Bill, you actually got criticized by some in the planetary science community for showing up at the State of the Union address.
Look, people, it's bigger than I am. The administrator.
Shame on you for having a dialogue with me, Bill.
Shame
on you.
So I went to his office. We hung out. We talked about fighter planes, among other things. We talked about his family, and everybody. This is something else you learn in space exploration when you go around the world and meet people involved in it. People are more alike than they are different.
I will tell you, I was saddened by the grief he took.
Oh, bring it on. No, you guys, it's the State of the Union. It's a very important thing. It's in the Constitution, as is the progress of science and useful arts. That's in the Constitution, Article 1, Section 8.
Yeah.
So science is a real word, everybody.
But we all live under one sky.
I apologize for inviting him to the State of the Union, because he took a lot of heat for it.
No, it's fine, and it's progress. This is where people, congressmen and senators that don't get along on anything else, get along when it comes to space exploration. And part of that is the distribution of NASA centers around the country. And everywhere you go, everywhere you go, no, really, everywhere you go, NASA is involved. NASA permeates our culture in virtually every zip code in the United States. But more than that, space brings out the best in us. Space exploration is where we solve problems that have never been solved before. And I'm not just waxing poetic for the sake of oratory. I mean, space is really unique in this regard. It brings out the best in us, and we accomplish things that in my grandparents' time were thought unthinkable.
Well, we're running out of time. I don't know if you have any other final thoughts, because we've got like 30 seconds, but it's been a really good conversation. Otherwise, I think it's a really nice note to end on.
Yeah.
Good. So everybody, just while you're here, check out the Planetary Society, the world's independent space organization, and we are here, Mr. Administrator, to give you correct advice all the time.
That's good.
To support you.
I like correct advice. So, thank you.
Thank you.
Well, thanks to the panel. It was great having you here, great conversation, and we're on to the next part of our program.
Thanks.
Thank you so much.